of the length x. Okay, so we're going to do the same thing we did here. We're going to use a proportionality equation. We're going to get the accurate result, which you know is 45 from what we said before, but here's how it works out. Okay, we're going to say period y is proportional to the square of length x, specifying that we're using y for period, x for length. We don't want to write that in when you're doing it, constructing a good solution. Not something I'm going to be big on penalizing now, but we want to develop that skill for later, so it's a good idea to start doing it now because I will be expecting it later. Okay, so period y proportional to the square of length x means that y equals kx squared for some constant number k. Now you've done this, and people did this in homework and fundamentally did it right. But you're probably just doing it by rote. Right now you want to remember what you did. Hopefully those neurons are firing a little bit. Maybe you understand totally. Some of you probably do. But you know, if it's a little fuzzy, you know, make sure you lock it in. Okay, y equals kx squared for some constant number k. Well, y equals 5 when x equals 2, right? So, putting 5 in for y and 2 for x, we get this. I'm not going to go through the algebra details of solving for k. You're going to get 4k, you're going to divide both sides by 4, you're going to get k equals 5/4. So our proportionality equation is now y equals 5/4 x squared. Right? Okay, we've done all these steps. Okay, every one of these steps should be, and I think probably is, at least somewhat familiar to you because we did this a couple of weeks ago. Okay, so y equals 5/4 x squared. Okay, well, okay, again, y equals 5/4 x squared. So if x equals 6, y equals 5/4 of 6 squared, which is 5/4 of 36, which is 5 times 36 over 4, okay? Which is, we can reduce this to lowest terms. And quickly get 45, right? Okay? So proportionality equation, I mean, we've done quadratic models where you get 3 simultaneous equations for 3 parameters, right? We've done other models where you get 2 equations for 2 parameters. You get systems of simultaneous equation. This is much simpler. You've only got 1 parameter. That's your k. But we're doing the same thing. We're taking data, plugging it in, evaluating k, and then using the resulting function to get our result. Okay? Much simpler than trying to do a quadratic model for 3 points. Okay? So this ought to be something that you just totally nail if I ask you to do this. Okay? So there it is. And of course, this graph is the graph of y equals 5/4 x squared. Okay? So